So I'm recording this lecture to my personal computer. So I'm again not streaming this through the YouTube. Or Ilkka, would you mind if I put this through the YouTube as well?
Yeah, it's okay. Yeah,
That's
I
great
don't
because
mind.
I don't have that many subscribers in my YouTube channel. I think in this class is only pretty much participants, not more than that.
Yeah, that's okay.
And then this will be a double thing to do because if something goes wrong during this recording, it's always possible that there's nothing left from this recording. But in a YouTube, even if we're gonna break it in the middle, still is whatever we did. It's gonna be available through the YouTube.
Yep.
Okay. So now with that, I know that we have a limited number of participants, and maybe we're not gonna have a good conversation today because of the lack of participants. But anyway, so we're gonna have a very interesting visiting lecture that will be delivered by Ilkka Donokue, and Ilkka is coming from LUT Lens, and that's industrial engineering in particular. And well, you will tell your background a little bit, and you will just explain what is the deal with this product lifecycle management. So Ilkka, go ahead.
Okay, thank you, Aki. And just to check, how much time do I have, just so I don't go over, so I don't get over enthusiastic?
Should we ask that from the students?
Yeah. Well,
usually these visiting lectures are say 45 minutes to an hour, not more than that. There have been two exceptions. The one lecture that was delivered by Adam Glodowski, I think that was close to 2 hours, but it don't need to be that lengthy. And then the one that was last week, that was roughly an hour. So 45 minutes to an hour, that would be really perfect.
Okay. I'll keep it to that then. So I'll just put it into presentation mode, and so just briefly about my background. As Aki said already, I'm Ilkka Donokue, and I come from the Engineering School of Science, and I come from Industrial Engineering Management, and I work as a PhD student and researcher there, finalizing my PhD on intelligent product service systems. My background, I bumped into product lifecycle management in the year 2000, and since then I've never really been able to get away from it. It's always been part of my work. And I've actually seen the evolution and implemented product lifecycle management principles within companies in the different industries, aerospace as an example, telecommunications, then also heavy industry, and then mineral processing, to mention a few. This is an interesting way to give this lecture this time online. So if you have any questions, let's try to keep to the normal way of going. That if you have questions, ask, and I will try to answer them as we go forward. Or then at the end, we'll try to reserve some time to go through the questions. So this is really an introduction to product lifecycle management, and I'll give you some backgrounds. And I actually thought about the table of contents, what I would talk about, and I listed it into three areas. I tried to give you a background of product lifecycle management, what it is sort of and where it came from, just a short historical view. And then obviously when we talk about products lifecycle management, one of the key things is that we're actually managing products and services. And I'll try to explain what is happening within the product lifecycle management domain and what the original sort of idea of it was. And then we'll actually talk about product lifecycle management itself, what it is, the basic concepts. And this will be a sort of introduction to the topic. There's a complete discipline behind this, much deeper, and you can find a lot of good literature around it. So if you have any questions later, please feel free to contact me. Okay. So historically, when I first started to look at product lifecycle management, there was this idea that and thought that, hey, at the end of the day, products in companies are really the information that the companies are managing. And Bill Gates quite well put here that how you gather and manage and use information around your products will determine will you be successful or will you win in business. And from the starting point, product lifecycle management really was always looking at the factors of how do we manage our product information right from the initial sort of business requirements all the way to development, then also into manufacturing, and then also when it's operational, and finally, how do we make a decision to retire the product and recycle the bits and pieces of it. So one of the guiding lines that we had in Elcoteq, one of the companies I worked for, was that product information management actually stands for and is a driver for business and product development, and especially this business development. If we can manage our products and services efficiently, we can also then in the future be successful as a company. So this was a little bit of a historical point of view where I started from. If we look at it also, the idea of product lifecycle management is not particularly new. It started already in 2000, and really it came out of the idea is that there was this first generation of knowledge management, and what companies were looking was that how to integrate information, which was basically existing data, and turning it into information that companies could use to make decisions. And this created this information knowledge management discipline around industrial engineering. And it was seen that processes created the data, and that if you could manage those data efficiently and understood the data and then turn it into knowledge, you could innovate around it. And once we moved to the right-hand side, there was a second generation of knowledge management where they started to look more and more into the digital tools. This actually started already earlier with partially processes and paper documentation, the product management and product lifecycle management discipline. But as we moved forward into the year 2000, we started to actually look at the methods, tools, and systems, and they became very key for companies to succeed in this area. And a lot of companies invested heavily in 2000s into ERP systems, but also into PLM systems, and the business benefits changed depending on the company you were working with, or you were who were implementing it. But in a nutshell, the history really came around with the thought of, if we manage our business processes, we have the digital tools and methods and systems in place, we should be able to manage that data, and that data should be able to be used for innovation, product innovation, or manufacturing innovation, or service innovations. So that was the historical point of view of it. If we move forward, then obviously looking at these trends of manufacturing, this is again from a more historical point of view. Product complexity is increasing, and this is still going on today. But this was already going on when I first started working in the PLM field. And typically in Finnish industry, where you have business to business type of engagements, that they were one-off configured products, and complexity was increasing. So at the end of the day, it meant that the extended product definition, how we define our products, and the number of product variations and the technologies used within these companies was becoming more and more complex. At the same time, there was this need to build up networked enterprises, and this really means that, hey, that one company, if you take an example like Outotec or Metso in Finland, these companies not only working on their own, developing their products, they're very, very dependent on their suppliers and partners on defining their products and deliveries to their end customers. So building these networks was increasing and is continuously increasing as we move forward. Then also the lifelong view of the products and business. So typically these type of products that which I worked with and many companies face, they have long life cycles. And that means that the company that sells the product then has to maintain it over a period of can be from 5, 10, 20, 30 years. And depending on the industry that you're in, it can be 40 to 80 years. As an example, the B-52 Stratofortress that Boeing designed in the 1950s will have a total lifespan of about 80 years, the airframes. So those aircraft have been maintained for 80 years. The internals of the aircraft have been modernized and upgraded as we moved on. But at the end of the day, the same airframe will live for about 80 odd years. Okay, So this was the sort of trend that you sort of noticed, that you had these complex products, you depended on your network enterprise, and you had long life cycle products and businesses that you were engaged in. And it basically mean that the observation period was extended of the product. And this means that, hey, if this is the case, how can you make more revenue and profit out of more than just selling the product in a transactional point of view? I'd just like to highlight one additional thing here. Is this management of a uniform product information is increasing. So this has always been something they realized that, and we've realized that you need to maintain the information of the product. And the question has always been challenging for PLM, that how do you connect the existing product that is being used to the actual design or manufactured information that is digital within the company that has produced it, and how can you get the operational information, how the customer is using the product back to you? So there's always been this idea that if we manage a product over a life cycle, then we need to have a uniform way to define the product and have that information under control. If there's no questions, I'll move forward to the overall idea. And this is actually a very important picture. One of my colleagues has drew this some time back. But why? Why are we talking about product lifecycle management? Why is it important to manage the products? It's really in this one picture. So if nothing else you can remember, this would be one of the key pictures to look at. So if we look at the right-hand side where we have this pie chart, at the end of the day, the value of a product, the capex part, which means the investment, buying the car or buying the aircraft or buying the ship, is this one-time investment that they have. And that the company gets a certain amount of revenue from here. But if we look at a product that lives 10 to 30 plus years, there's a lot of revenue that can be made in the service business point. So this picture is basically trying to highlight the cash flow on big complex systems. The one-off sales, if we look at B, which is the machine delivery and setup services, is quite considerable, a one-time revenue recognition. But as we move forward in time, there is a continuous trickle of services that we can offer. If we look at C and F, for instance, here you have this preventive maintenance. It basically means that to make sure that your product runs as it is intended, the performance stays the same. For instance, in the car example, change your front brake pads on time. It's good to actually stop the car instead of with the brakes, then banging it in the back of another car by not maintaining it. The other area is the spares and consumables. For every car, like the brake pads, or you have certain type of things that have to be replaced. They just break or they wear out. So this has been the traditional idea of, hey, this type of service business we do. But moving forward, there are other peak areas which typically you can see in heavy industry and business-to-business engagements, where you have this D, cycle optimization service, and new software. So you can actually update the product as you move forward considerably. Tesla is a good example of this, where they are loading software with new features as they go forward. And then if we look at the E part, we have at some point of view the product, and this is a very good example in the paper industry, paper machinery like Valmet, where at the end of a certain period of time, the product is just not efficient anymore. It uses too much energy, it uses too much water, it breaks down, and you get into this machine modernization services. So at the end of the day, you make a big decision to close down a certain product line, and then you rebuild it and you modernize it to the latest technologies that you can bring it to make it competitive again. So again, from an OEM, a product provider, service provider, this gives additional revenue. And then as looking at this C and D part, again, you have this preventive maintenance until you get to a clear decision that the product is actually then taken out of service. And this was the original idea of product lifecycle management, is actually to maintain the product from the initial design to the actual delivery, all the way to the decision point that the product is actually retired from service, and its parts or components or modules, assemblies, are then either recycled or then scrapped. So this picture really is trying to highlight the fact that when we look at products, at the end of the day, this one-off transactional business that many companies have, industrial companies have today, is not enough to survive. But they have, on the other hand, a long tail here that they can sell services around. And companies like Rolls-Royce, Power by the Hour is a good example of this, where they're not selling jet engines anymore. They're actually selling performance for aircraft on an annual basis. Looking at this picture, obviously, we're looking at it from a relatively traditional point of view, where you have a product, and then you build services around it. Some of them, like we spoke about, spare parts, consumables, they've always been there. But what we now see, and what is becoming more and more a competitive advantage, is the data-driven services. So if you have a product in operation for 25 plus years, the operational data that you can collect on it is vast. Previously, if we go back to like 10, 15, 20 years ago, it was quite difficult to collect the data. Number one, you didn't have the same type of technologies available on information systems level, and at the same time you had this very sort of proprietary thought within companies that their production information, how they used products, was their sensitive business advantage, that they didn't want to share it. But this has changed. So looking at this picture from a more modern point of view, you can start to see that there's a huge amount of data within this tail end that you can actually start to collect. And also there is a huge amount of potential around understanding the data and simulation in the front end. So the original vision of PLM, of bringing a life cycle management of a product, was difficult previously, to use the fact that you couldn't connect the product and the actual design data or operational data together. So moving on, just looking at these common views of products and services, and this is a relatively old photograph picture I have here, but I'd just like to go through it quickly. So traditionally, when we talk about products, the first one is this equipment product. So we typically think about standalone products as such, and this is what most companies work at some level. When we go into more complex solutions, you have this example. If you can see my pointer, you have this drawing on the left, which is a 3D model of a plant layout. And this is sort of stating the next level of complexity, where you have a group of equipment products that you start to put together to create a unique customer solution. And this is very typical when we go into the heavy industry areas and mining and metals industries, where you're actually starting to collect groups of products and creating business, certain type of production processes, and then building plants like power plants or paper mills or mineral processing plants. And this actually here, this picture is an example of a mineral processing plant. Again, looking at 1 and 2, these two things, just like this, we're actually really looking at CapEx projects, where the customer makes a decision: I will invest in your equipment, or I'll invest in your complex solution, please deliver it to me. They will buy certain services on the side, but we'll come back to that later. But the basic idea here is this is the CapEx delivery. And then after this, it's operational, but somebody needs to support it. So typically companies have started to design afterwards, or at the same time, certain type of services. And this is an example. 6 is diagnostic services that the customer will buy. Somebody to consult them how they should run their plant or equipment better today. Then the other one is, we spoke about the end of the life cycle, this point 8, which is a shutdown service. At the end of the day, or you make a decision, we will upgrade this product, or we'll modernize it, or we will shut it down. So basically, the company like Metso, Valmet, Sandvik comes and actually closes the plant down and then rebuilds it. So this is, for me, 1 to 3 is pretty traditional type of business model. But when we get into this area where we start to talk about part 4, we get into an interesting new trend, product service systems, where actually you start to notice that the product and the services are designed and offered together. So the actual product, its physical product itself, is not anymore the key thing. And here, as an example, there's the logos there. One is Apple, which we can use as an example. Apple was a good example, and Android telephone is a good example of that, where they saw the actual telephone as a way to offer additional services. It wasn't anymore the key thing that, on the other hand, Nokia had, where they were selling the telephone. That was their way of thinking, that we will sell a telephone and then we'll sell services. Android and Apple were actually looking on the opposite point of view. They were saying, we will sell a telephone, but our real business is to sell all the other services on top of that, like iStore offers today. And then we have some examples here, like General Electric, which have made the clear decision to create a complete digital platform system where they can actually connect their aircraft engines or power plant systems with that platform, and then offer to their customers services by the hour, like I said earlier, Rolls-Royce are doing. And then final interesting area, which is clearly noticed, is raising its head, and this is just an example, is the intelligent product services. And they create a complete ecosystem where we're actually starting to bring the actual products and the services together and the digital information, but we're giving them a certain amount of intelligence, so they understand what they're doing and they can behave in a certain predefined way. So this is, as a sort of stepping stone, we have gone from a basic simple product, which is typically mechanical, to a complex product service system that actually has a certain amount of intelligence behind it, that relies on data that it has available, or simulation models that it can utilize to understand what and how it could behave. Any questions so far? If not, I'll move on. So, trying to bring this all together in one picture. We wrote actually a paper about this, and this picture was actually in it. So the basic idea here is that, okay, on the right hand side, we have the physical product. So what we're talking about is a new trend that is happening in the PLM domain. We spoke about the need to manage the product information, and typically we would think about the basic product information, defining it, like the drawings, the assemblies, the documentation. But today that isn't enough. We're actually in a transition period where we have the product service systems, that is actually the product, the physical product, and all the services around it combined together, and that is then delivered to the real world. So what we define here is the connected physical world product to the actual virtual world, which is the digital twin. And what we have stated basically here is that on the left-hand side we have the physical product that is then manufactured and delivered and maintained according to traditional product lifecycle management methodologies. At the same time, we have a connected virtual digital twin of this product. And here we're saying that there should be a connection between these two products through two directions. One is the simulations that actually define the product before it actually becomes part of the real world. And once we start to manufacture or test that product and manufacture that product, then and deliver it, then we connect it to the real world example. And once we have done that, we have the simulation model that is actually defining the product in advance to existing in the real world, but then we start to collect the data from the real world example to understand how is it actually being used to improve the future generations of the products. And here we're basically talking about utilizing IoT platforms to collect then the actual operational data that we can use then for service-driven business opportunities, or then alternatively the simulation that we can run certain scenarios, how this product would operate based on this operational data that we have. And this is really one of the key aspects from my own point of research that we are able today to fulfill that product lifecycle. Original vision was to manage the product from design all the way to the end of life. And through this, we can actually define the product before it comes into reality using simulation models, making the product development, the product new introduction, and the product manufacturing quicker and more cheaper. But at the same time, once we have it in the delivery done, we can actually start to collect the data back and utilize that to define new services or new developments within the product itself. Okay, I will move on if there's nothing. So why, I'm now mentioned about this digital twin, and why is it relevant to product lifecycle management, and why is it important? This is a slide from Siemens, and there's many like it, but if we look at the heavy equipment industry, and which is typical what we're looking at, or I'm looking at, then the reality is that there are more stringent regulations. There's more requirements put on products each year or each generation than previously, which means that you need to find the data, how the product has been designed, how the product has actually been verified. And it's not enough just to have the drawings anymore or the FEM calculations. You actually have to start to show the simulations, how it would work, how has it been verified that it would work throughout. Another area is this multiple variants. We're in a situation where everybody's not driving a T Ford anymore. Everybody wants a unique product, and the customer requirements are changing within the consumer side, but also on the heavy industry side, where you typically have always had unique solutions. So there's multiple variants that you need to manage, and you need to design them at the same time and make sure that they work as you planned. You can't build physical models, test models for every single product variant you have. You have to do a certain amount of testing within the actual virtual world. Then obviously this productivity and cost of ownership, we spoke about this. This is clear that customers are not buying anymore just equipment, they're actually buying productivity, they're buying services, they're not anymore just buying the CapEx thing, they want an outcome. And this is maybe the big difference that has happened over the last years, is this outcome-based business models that are becoming more and more dominant. And then finally, we've heard a lot about this equipment autonomy, and it's in the headlines, but that is a reality that more and more companies are looking at this, that they would like, why have a person in the loop? Can we do things where the equipment does it autonomously without the driver? And this requires obviously a completely different type of understanding of the product definition data, but also the operational data. And to get to that, you still need to be able to simulate in the virtual world how this all will come together. Okay. So this is looking at the same thing from a slightly different angle, but just to highlight and summarize here, really, on the left-hand side, the traditional, well, 10, 20, 30 years ago, a lot of the heavy machine manufacturing companies are looking at the products and services as two different entities. And even though they would typically offer them to the customer at first sales together, but the reality was that many of the services would be defined afterwards. When the product had a certain type of problem that occurred, they would create a service bulletin and a service kit to improve it or correct it. But where we have gone now is really that the product is in the core still, the physical product, but we have built the services around it and defining the services all the time as we go and develop the product. So we don't create only the physical product, we also create the service product at the same time. Once we have, this has become dominant, and as technologies move forward, the data becomes more and more important. How we manage the data that is done when we do the product development, but also at the same time when the product is out in the environment being used. So collecting that data back and understanding how it affects the services that we have defined, and also the product that we have offered to the actual physical product we have offered to the customer. And finally, if we look at these layers, we have this interesting point of view where we have these new business networks where companies who are providing, for instance, the products and services and offering the data, they can actually create additional business partnerships. As an example, if we take, for instance, Finnair. Finnair are responsible for turning around their aircraft relatively quick at Helsinki-Vantaa and then getting them back up in the air with the passengers. Before they can do that, they obviously need to refuel the plane, etc. And this is a common process that exists. But one of the areas where they were having problems was in the cabin cleaning. So what they did was that they had outsourced this responsibility to a company called Sol. And for Sol to sort of be able to communicate fast and efficiently to Finnair, they said they would create for their cleaning crews an application that when they went into the aircraft, the team lead would do a quick sweep of the aircraft to see what was the overall cleanliness level of it. And if it was normal, he would just inform that normal cleanup is needed, and then the Finnair would know, and then the Finnish aviation authorities would know that, okay, this aircraft can be turned around on time. On the other hand, if it was a complex maintenance thing, there was something broken, or there was somebody had felt bad and thrown up, they would notify then the Finnair, and then Finnair would notify Finavia that this is not a normal maintenance, it will take longer than usual, and then they would make the decision to what they would do with the aircraft. However, Finnair needed this information for themselves to know how quickly they could turn around the aircraft. At the same time, Sol was able to collect information, how long does it take to typically clean certain type of aircrafts as they moved forward. So they knew that the service they were providing was within the service level agreements that were available. The additional business network player that came into this was actually Finavia, who are the Finnish airworthiness authorities, and they are the ones responsible for all of the airports and the time slots for aircraft to land and take off, and then also to approach the Finnish airspace. And for them, this information was offered throughout Finland, so they could also see and optimize their flight plans when certain problems occurred. So this is an example of where the business network can bring in new players, where you can offer data to people you would typically not communicate with directly. And this was basically built on an app that Sol did for themselves, that was offered to Finnair, but at the end of the day, the person who had a big benefit out of it was the Finnish airworthiness authorities. Okay, long example. So just what I would like to also sort of highlight here is that when we talk about the products, what we see, and this is from Baines, who's studied this area, product service systems a lot. The overall concept here, another important picture, I would say that when we talk about products and services, depending on the type of business that you are in, you can have this approach versus products, and then you can start to build these products and services together. So you move along this servitization of products. and access, if you can see my pointer. And at the end of the day, you create a product service system that enables you to offer and understand the product over the complete life cycle. On the other hand, we have certain areas where instead of having products as the core business, you have services. And you start to offer those services one-offs and you tailor them, and you offer them to this customer in one way and the next customer another way. What you can also have, and which is another trend, is the productization of services, where you actually start to look at the services that you offer, and you actually start to create certain modular structures within those products to reuse certain service elements again and again. Don't change the engine in a car every time a different way. Change it according to certain type of service modules, which would be productized. So this idea here is that depending on the business area you start from, either product driven or service driven, you will go through this product service system evolution. If you're product side, you bring the services in and you servitize your products. You bring the servitization aspect to it. If you're in the productization of services, you start from a service viewpoint. Okay, any questions? Okay, this I won't go into too deep. I'll just leave the basic, just the highlights here. You'll get this presentation. I can distribute it with you, but here's an example of just basically the relationship of information that is managed. If we have the traditional equipment product that we spoke about, typically you would associate services to it. That equipment would also have associated system software related to it. And if you had equipment products that built up a certain type of production process, for instance, a car painting line, that process would have the equipment, but it would also have its own controls software, and then it would also have its control services. And then if you had a complete car manufacturing plant like BMW have, then you would be putting these processes together to create the overall plant, but then you would have the associated software to operate it, and then you would have the services to operate and maintain that plant. And depending on how this business application and customer is, basically if you provide a certain type of equipment to a business use, for instance, you could use this same type of melting technology to melt metal, but you could also use it to burn waste and create energy. So this is a business application, and then you could then define your customers behind it. So this is the basic logic behind product lifecycle management, that you have a set of product types that you relate to each other, and they build together a structure, and those structures will live over time. Okay, and looking at it from a more life cycle point of view, what companies typically end up doing, and this is one of the key product definition things that was utilized in one mining metals technology company in Finland. This framework. So what they realized was that their product life cycle was divided into three separate stages. One was the actual product management effort in research and development. The other one was in the sell and deliver, and the third one was in operations. And when they looked at their products types, they realized that you had a customer need, and at the end of the day, you needed to fulfill this customer need. And what they realized when looking at their products is that, hey, they can categorize their products product definition by A, B, C, and D. Based on the type of deliveries that they were doing and the type of customers they were engaged with, they were delivering products that were partially defined. Nothing was perfectly defined to the end of what the customer needed. So here, the product definition A, B, C, and D was just saying that, hey, if we have an A-class product, then it's about 80% defined. So 80% of the product is ready for customer delivery. Down to the fact that you have a D product that is not defined. You know you have the technologies, you have the competence to deliver it, but it will always you will order it to the customer specification. And this is okay. Companies need to understand this, that when they look at their products, that based on the type of customers and based on the segment that they're working in, the product definition needs to be good enough for that business. And this, when I talk about products, I'm always talking about here the physical products and the services built around them. So here, as an example, this particular company recognized that it had A level products that were typically configured to order. So when they sold them to the customer and delivered, there was a certain amount of engineering needed to deliver it to the customer's needs. But at the same time, they knew that they were entering into new type of application areas that was engineering to order. And this would always be one-off design. For instance, a lithium plant was something that was discussed about. It could be delivered. Haven't done it really before, but we need to deliver it as a one-off. And that was the engineering to order for that particular customer. But the basic idea is that at the end of the day, regardless what level you start with the product definition and define it in the first part of the life cycle, when you sell it and deliver it to the customer, it has to fulfill his customer needs. And once it's in operation, that's when you start to offer the additional after delivery services around that product. And these can be, as we spoke earlier, spares and wares, but they can also be data-driven services like monitoring services, monitoring how the plant process works or how the car is operating. But at the end of the day, sometimes the performance drops, and then you need to fulfill the customer needs again, and then you do these maintenance or upgrade or modernization services spoke about. So if we look at the life cycle for most companies, at the end of the day, you have the product management and product development cycle, where you're defining the product at a certain type of definition level that is sensible for that industry that you're in. And once you have this available, then you have a portfolio of products that you're offering and services, and then you sell and deliver them. And typically, there is in the business-to-business industries, you are doing a certain amount of configure to order or engineering to order, somewhere in between here. You deliver it to the customer specification, and then you start to look at the third phase, where you actually support the customer in operating his products. From a customer point of view, they don't want this first life cycle and second life cycle part. They just want to get to the operations as fast as possible. So a lot of companies are actually looking, how can they make their sell and delivery processes more efficient? But at the same time, they have this other key area, how can they make their product development time shorten? So how can they renew, how can they maintain their product portfolio or service portfolio at the best possible change rate within the industry that they work in? So this is just a quick first look at what product lifecycle management looks like. So based on the maturity, you deliver a solution to a customer. At the end of the day, you start from something you have in your product portfolio. Any questions? Okay. Next slide that I have is this product and service dimension that I'd just like to go in a little bit, because this is something that companies many times struggle with. Is that if we look at the X and Y axis, typically, if you can see my pointer, we have the scalability and product continuous improvement. We know that you can take a certain type of product and you can scale it up. You can use basically the same architecture to a certain level, and you can reproduce it. This is an example of a flotation tank from Oldertech, where they started with 50 cubic meters and they've been able to scale up the same technology always up to 300 cubic meters. So this is one aspect of how products are managed based on the platform. At the same point of view, we spoke about this integration where we start to take the actual equipment, products and systems and product lines and plants and integrate them together. But at the same time, we need to identify the spares and wares that are used and the technology platforms that we are utilizing. If we deliver these type of solutions, typically, if we talk about companies like Valmet, Outotec, Sandvik that are delivering complex solutions, you can't just go and buy it off the shelf. You need to have a certain amount of delivery services that are offered when delivering, for instance, this flotation tank 50. Once it's up and running, you have these post-delivery services that you offer, spares, wares, modernization, upgrades. And then you have the third part, which is these new services that are utilizing information that you're collecting. So that is the third service area that was identified, and this is a real example actually from a company. The way they sorted this out for themselves. However, an area that is challenging sometimes to recognize what are the pre-delivery services that you offer to the customer before you actually start to deliver anything. And this is something that this particular company recognized that, hey, at the end of the day, we are doing feasibility studies, we're doing certain type of business cases, we're helping our customers to get investment from different areas for their plans, business plans. And they started to create a certain pre-delivery service portfolio also. So when we look at the product that we're actually managing, we are looking at it from multiple dimensions. We're looking at it from a scalable product which has continuous improvement needs, which is more akin to the product development cycle. We have also this fact that we have technologies and we build up from equipment all the way to complex plant solutions. But to get there, we have the services. Some of them are pre-delivery services, some of them are post-delivery services, all the way to these new data-driven services that are listed here. And this is a new services with IoT. This was drawn for a certain company about 5 years, 6 years ago, something like that. So this is a case example. So when we look at it and we talk about managing products, first, the most important thing is to understand what do you mean with your product. Product lifecycle management is relatively sensible and common sense discipline, product managing the information. But at the end of the day, the question is that what do you mean with your products? What are you actually trying to manage? And this was as the examples I've shown, these companies have tried to understand how these different type of elements that come together and define the product portfolio that they need to manage over the life cycle. Just briefly, from a service point of view, I'd just like to highlight this business-to-business service classification framework. This is actually from, you can see the reference down at the bottom, but this is actually really a good view of how we can look at services and how a company can start to define what they're trying to do on the long term. So if we look at the area 1 at the lower corner, product lifecycle services, what we're talking about is basically you're offering services around a product. At the end of the day, you're looking at it from a product point of view, and you're doing sort of delivery of, for instance, you deliver the cables to an industrial supplier, or you send the spare parts to that customer that you have. So what you're actually doing is you promise a certain to do a certain job. The next area, if you're on this product element, you're focusing on your products. You're looking at the asset efficiency services at the next level, where you promise that your product will perform at a certain level, and you'll make sure that it works at that level. But you promise the performance. That's it. But you're looking at it from your product point of view. And this is the one and two very traditional ways of looking at product service systems. when you move to the right-hand corner, you're looking at not anymore your product centric. You're actually looking how your customer is using the product. And here you have this product support services. So the product support service is the traditional consultant say, hey, could you come and tell me how I should run this product line more efficiently, or tell me how I should optimize certain type of repair. So this is really bringing in an expert who looks at the way you're running your processes and says, hey, you could do it a different way. Traditional IT consulting is very much like this. The final part is really the point that the customer delegates the service. It delegates the actual process to some outsider. So what they're saying really here is that, hey, that you have the best expertise of manufacturing, for instance, telephones. We will buy this as a service from you. You take care of it, the manufacturing part. And this is really the complex level. And this is something that companies are doing today more and more. If you look at the complete ecosystem, the way today telephones, electronics is manufactured, your iPhones, iPads, whatever, they are done with this, where Apple don't manufacture the products themselves. They give it to Jabil or Foxconn or whoever they are nowadays, and they take care of it. The same thing with the Xbox. Microsoft, as an example, says we want this type of gaming platform, and they then offer the complete development, manufacturing, delivery to a third party. So looking at this product lifecycle management that we spoke about and how it develops, when you start to look at it from the service point of view, you can also start to identify new business opportunities, how companies can change their way of doing business from solely physical products to more service oriented. Okay, so I'm just looking time-wise. Yeah, if we look at this if we look at the end of the day, so when we spoke about overall products and we spoke about the life cycles, and the whole idea has always been this closed-loop product lifecycle management. So when we talk about product lifecycle management, what are we talking about? We're talking about a way that all actors who have a role within a product or service can track, manage, and control the product information throughout its life cycle. And the idea here is that when you need that information about the product, if it's in product development or it's a new product introduction or manufacturing or out in the field, you have access to that information. So you should be able to get that information anytime, anywhere in the world. And this is really the whole logic behind a product lifecycle management, and it has always been that. Let's bring the product information together, let's maintain it throughout its history, and give people access to collaborate on it, to understand how the product is being developed, how the product is being delivered, how the product is being operated, but at the same time understanding what are the future product opportunities or service opportunities you can build. This was actually the last slide I was planning to show. And I think I'm actually done for time-wise, actually quite well also.
So Ilkka, if you hear me, so it's 55 minutes or so from the beginning. So
yeah.
So it's 55 minutes.
Yeah. I mean, I have a couple of other slides I could have shown, but just for backup. But this is the core thing that I wanted to show. I could, are there any questions? Does this make sense? Is everybody awake?
Yeah, look that all the students are muted, so I don't know if they want to make any comments.
Okay.
Also, not because the thing is that now this comes from the two different sources. This comes from the stream, but also from the YouTube. Sometimes the comments are coming from the YouTube, but I cannot really see if there's any comments. I guess no. Yeah, no comments or questions.
Let's check one thing. I'll just see if is there anything. Yeah. Okay. Just if I can say, okay, I'll show one more slide.
Sure.
Yeah. Okay. So this framework slide actually was defined for one company, and this really highlights the whole thing. So just to summarize one more time, if you look at the red arrows at the top, the product life cycle, you have product life cycle 1. That's basically your product in your portfolio. And again, we're talking about the extended product. This is what you are offering. And traditionally, the marketing process, research and development, market, and then the first part of the marketing process are part of that. Then you have the second life cycle, which is this delivery, where you actually sell the processes that you utilize is to sell the product and then deliver the product. And that's the third life cycle, getting it out your door and having your supply chain engaged in the delivery. The third part is then this instance in operation. So this is the third life cycle, when it's actually out in the field being used. And if you look at this, when you will bump into the reality that there's certain people looking at these research and development processes to optimize them, or sell process or delivery processes. Product lifecycle management's role and responsibility at the end of the day is to ensure that you have a smooth end-to-end way of managing the product information throughout its life cycle. So its role is to do this primary, but at the same time it should also be collecting the information from the different phases back and pushing them forwards, intervening in advance or correcting things that have been done previously. And one of the areas really here again is this internal and external feedback loops, which can be done through simulation and then using these data-driven platforms, collection platforms, like using IoT platforms. So this is just the last slide. I thought I could just summarize up. This is the basic core of PLM. You can make it more complicated, but this is really it. So if you have any questions, please feel free to ask. Or if you want to come back later, then you can contact me via email, for example. Okay, thank you.
Thank you, Ilkka.
Yep.
Now what follows is that next week we'll go back to my lectures. What I really wanted to do next week is that I wanted to try to give you a big picture, like how everything is related. The work we do, PLM, all these applications that we discussed previously. So that's a great challenge, but that's what will follow starting from next Monday. But thank you, Ilkka. So I appreciate this very much, very clear, and I think that the recording was fine. Of course, you will see the YouTube recording. I noticed that there was a little bit of background noise, but that was because of the settings. But other than that, it was really nice. So thank you very much.
Okay, good. Thanks. Thank you very much. And thank you for being able to come and talk about PLM.
Okay, thanks guys.
Okay.